All right. Welcome to the first Haskell and Coffee, or Haskell somewhat bound to coffee. And some of you, this may be evening, so you can't really have your coffee now, but some of you, this may be tomorrow morning. So, you know, we understand different people have different coffee regimens. My coffee regimen this morning, I don't know if you can see, is here. It's from a company called Black and White Roasters in North Carolina. And they are a Black-owned business that does a fantastic job with their roasts. And today I'm drinking Ethiopian coffee right here in my thermos. So I'm going to unmute everyone and let's see. Anybody want to talk about what coffee they're drinking this morning? Yeah, I think you can now unmute yourself.
I have a Heart Roasters Colombian. Heart is from Portland. I had not heard about Black and White though, so since I'm here in North Carolina, I'm gonna have to check that out. So yeah, good call on that. I've also got my Collectivo shirt on from Milwaukee. So
re-election, Colombian coffee. Great.
Yeah.
Yep.
My wife is Colombian, so if it's not Colombian, I'm gonna have a problem. So.
I'm Narendra. I'm from India, and we are at night, so we had our dinner. No coffee, but
No coffee.
feel excited to have this session. Thanks for the arranging this and.
Where are you from, Narendra? Sorry, I didn't hear. Where are you from?
I'm from India.
Okay.
Yeah, it's almost night, 11 o'clock. So we had our dinner, no coffee.
Yep.
But yet excited to have this session, and expectation is a lot from this session.
Yeah, so we might be expecting a variety of people, some people who have never touched programming language, some people who have only programmed in you know, imperative or other styles of programming, and then we've had people who've had some experience with Haskell who are on here. So we're going to have to start all the way from the ground up. We're not going to do like we're not going to do like an intro to programming in this class, but we are going to do an intro to Haskell, and it's okay, because if we tried to teach you an intro to programming in this class, the problem is that most you know, intros out there that we would maybe build on are done from an imperative standpoint and not from a, you know, this is what a functional programming language is. So Haskell is, as we all know, a little different from most other programming languages that are in the mainstream, but Haskell is used for a lot of different things. So I'm glad to have you, Narendra, and I'm glad to have everyone else here. I'm gonna mute everyone again just for a little bit. Okay, so my name is Eli, and I'll be your instructor, although I'm at some point soon, I'm going to figure out how to get other people on here as hosts or co-hosts. so that we can get a little more perspective about, how to, let people share screens and stuff like that. I don't know if, let me see. Yeah, I think, yeah, once I get the settings up, probably for next class, we'll be able to have share screens. But I'll look into that as well. The idea here is that we'll have some lecture in the future classes. Today's lecture is more about making sure your system can run the GHC, the Glasgow Haskell compiler, and that it can install modules that we'll need throughout the class. Generally, we're not going to use any modules that are outside the scope of like the included modules, unless you want to. And one of the things we're going to talk about is having an idea to create a project for yourself throughout this class. I'm going to say you want to probably keep it simple, because even though we're going for 12 weeks, that's actually not that much time. And the majority of what Haskell does, while there are sort of like graphical packages and modules that you can use for Haskell, the majority of what people do with Haskell is command line interfaces, applications that do things that need to be provable. There might be applications in sort of financial calculations or monitoring things. There might be all sorts of different applications, but I would probably encourage you to stay away from like the graphical things, because that's like a whole area that even I haven't really delved into, so I don't know how much help I'm going to be in that area. There are like our CEO uses, there are things like window managers for X windows that are written in Haskell and can be programmed by you using Haskell. And so there's it's called Xmonad, and there are all sorts of other things you can do with Haskell. So it is possible to do everything with Haskell, right? It is a general purpose programming language that is fully, Turing functional, and does everything that any other type of programming language could do. Yeah, we got somebody who posted the link to Xmonad. Yeah, so there's a lot of things that you can do with Haskell. All right, so let me take a look here at the chat right now. So we've got some questions about the Glasgow Haskell compiler. So right now, so it's the current version of the Haskell compiler, the most widely used Haskell compiler, the glorious Glasgow Haskell compiler, is in the 9.xx versions. And generally, I'm going to encourage that we stay on sort of like the long-term support version, which would be the 8.10.7 or 8 versions. And that is because when we're looking at, if you want to transfer your knowledge from here to the Plutus application backend or any of the Plutus programming situations that IOG or anyone produces, all of their systems that they're building on are using GHC in the version 8. And there are some major differences between 8 and 9. And so just like any semantic versioning would tell you, so there are some breaking changes into 9. And so some things won't work, or some things will work that don't work in 8. And so it's really recommended that we stick with the 8. All right, so we also got a question about provable like classic theorem prover or something else like mathematical rigor. And it's more in the mathematical rigor using lambda calculus and stuff like that. Although it is in the sense that you can prove a mathematical theorem, right? Similarly to any other type of theorem. And you just use the mathematical operations that are available to you for those proving things. And so the, let me see if there are other questions. Yeah, so 8.10.5 is fine, 8.10.7. Is Haskell used for AI? I have not seen that, but I'm sure it's possible. The idea for AI is that you need some system that can utilize the most important features of your computer in order to produce the best sort of results for that type of environment. So AI, and if we're talking about AI, most people are probably talking about machine learning. There are some things that like Haskell has, matrix calculation libraries and modules and things like that. And so there are things that can be used, but it's probably not the prime resource for something like machine learning. So the prime resource for something like machine learning is for development, usually something like Python. For implementation in a production environment, sometimes still is Python, but sometimes is something like C, C++. More imperative languages that have stuff built out, have libraries built out for those particular needs that allow use of like CUDA cores in NVIDIA processors and stuff like that. And yeah, so we've got we've got people giving good insights on the chat there. Okay, so going back to what we'd like to install, there are a couple of things that we want to get people connected with. First of all, if you go on your system here, and I'll bring this up on mine. Minimize this. Okay. All right. So if you go to haskell.org, and let me make this bigger for all of you. If you go to haskell.org, you'll see this is the Haskell site. They've got some interactive stuff on here, but what we're really going to be focused on for this lecture is the download section. You say, well, okay, that's pretty interesting. And the recommended installation instructions are to install that glorious Haskell, glorious Glasgow Haskell compiler, and the install process that's recommended for Linux, Mac, FreeBSD, Windows, and people using WSL2. I would recommend, if you're using Windows, to use WSL2. If you have not installed WSL2, when we go to the GHC up, which is sort of the installer and sort of manager of versions of GHC on your system. GHC, Cabal, Stack, a couple of other projects use GHC up to install the system. You can see here in the getting started, this curl here is a command, right, that it's a program that will allow you to make requests on HTTP on a web-based or an HTTP-based site. And so this get GHC up from Haskell.org produces a script that downloads the right system for your computer. Now, the reason I was saying WSL2, so WSL2 basically allows you on Windows to run a Linux operating system or a BSD operating system as sort of a thin layer under your Windows installation. And if you click, when you go to GHC up and you go to the WSL, it teaches you about how to install WSL if you're on Windows. And I really recommend this rather than doing, so there are other options you could do to get a Linux sort of subsystem. You could install Docker desktop, you could have a Docker image that you have some virtual volume mounted to, but the real benefit of WSL for Windows is that it's a much thinner layer than Docker, and so it's much faster. So your operations will run faster. It's super thin layer. So running it is pretty seamless, and you get to interact with the directory structure pretty easily from inside, like your file browsers and things like that. So WSL generally the way to go if you're running on Windows, and then from inside whatever operating system you install, so say you install Ubuntu, or say you install Arch Linux, or say you install something, when you go in through WSL, you'll open a command prompt in that subsystem. And then once you've installed that subsystem, then you'll do this command, this curl command from inside of that terminal that's running in WSL. For Linux, Mac OS, and FreeBSD, you just run this directly. Linux will always have curl. I mean, like 99.99% of the time. Mac OS has curl. FreeBSD generally has curl as well. And in the standard installations, you know, because most people, the way you're accessing either packages or things like that, before you have any package manager or anything like that would be something like curl. So they generally most installations, most flavors of Linux have that curl already installed. But if you don't have it, we can talk about how to get curl. You might say, I don't like the curl pipe sh. That's an option. You can do other things, right? You can do do a manual installation. You can download it and place it in your path. That's totally fine. But generally, the curl sh generally good for anybody's situation. So I'm going to unmute all of you and see if there's anybody who hasn't gotten started on this, and anybody needs help on getting the GHC up ready and running on their system. So I'll also enable screen sharing. So if like you need to show me what's going on, I can enable screen sharing for you and let you share. Okay, let me unmute. Okay. So you should now be able to unmute yourself if you need to discuss how the process might go for you on your computer.
A question with macOS. So I ran the curl prompt. It gave me back a response to detected ZSH shell on your system. Do you want GHC up to automatically add required path variable? And it gives me a couple options: prepend or append to the path variable. And I looked it up, and it looks like prepending potentially causes problems with other things.
So prepending it is the default way when you're installing something that you expect doesn't exist anywhere else on your system. And the reason is the prepended ones, things that come earlier in the path variable are executed first. So if you prepend it, the GHC that you're installing now will take precedence over any other GHCI or GHC that you have in your system. If you append it, if you've already installed GHC somewhere else and you don't execute directly the complete path of where you're expecting to start your GHC from, then you might come up with some problems if you append. If you prepend, generally for this installation, probably okay. And if you're running ZSH or Bash or Fish, I think GHC understands how to make sure that your path gets updated in whatever RC file you have setting things up. Now, if you're running Windows, anybody have any problems so far on Windows? Yeah, but somebody said, and if prepend bakes anything, undo and append. And the way you undo is you edit your .cshrc or .bashrc file, and you take the section that says, GHC whatever, and you take that section from the beginning of the string up to the colon, and you put that at the end of the path variable. Generally, what people have in their path variable would be path equals, and then some quoted string that has colon $ path at the end of it. And the append, you'd probably want to still put the new directory before the $ path. So the colons are usually a separator between different directories that you're looking for things in order, left to right on the path. Jaime or Jamie?
Jaime, you got it right.
Yeah.
I just wanted to ask, is stack needed as part of the installation?
Okay, so it's not needed. We aren't really going to touch stack. Stack is useful for building projects, although the majority of projects that you see out there for like Plutus are going to be Cabal based. Cabal really is all you really need. Stack does some things like lets you install other packages easier for certain things. But generally we're going to be using Cabal only. We won't necessarily need stack. And also if you don't install stack with the GHC up, you can install it later if we find a need for it. It's okay not to install it if you're optimizing for space and things like that.
Okay, thank you. Also, are we troubleshooting at all, or should I?
Sure.
I gotta fail on my installation.
Okay.
I'm installing it on Linux.
Okay.
And yeah.
Let me see. Let me allow you to share.
Just a quick question. Do we install Haskell server language?
Okay, so the Haskell language server is an excellent tool if you're going to be programming in Haskell. And what it does, like any other language server, like the TypeScript language server or any of those language servers, is it allows your editor to interact with the language server to diagnose problems or suggest potential answers to untyped things with that language server. And so it's really helpful in especially starting to program for things like the GHCI, which is the interactive shell. You don't really need it, but for programming in files, we're going to be doing pretty shortly, you probably do want to install Haskell language server. I use it all the time. I use it in NeoVim or Vim, but you can use it also in VS Code and any other service that can connect with a language server. So I'm going to take a look here at Jaime's screen. Hold on, let me see. All right. Interesting. What was the command you ran to get where you are there in the errors? Was it just it was just the curl? Type sh space dash dash version. I want to see if your sh is actually oh, what is it? It's sh. Let me, because some systems like Alpine and other things, instead of having sh, they have bash, but that's called sh.
It's a single dash instead of a double dash.
Oh, a single dash, single dash. Okay. Oh. Try a dash v. No ver. Just nope. Okay. So type exit. Let's do, just for kicks, type man, man space sh. Let's see if that just tells us which sh is. Okay, so it's dash. It's not sh. All right. Q, type Q. Type man bash. Let's see if you have bash at least. Looks like, okay, so Q, and then type Q, and then press up a few times till you get to your install.
Sorry, press what?
Or just either press the up arrow or do the curl again. But instead of typing pipe sh, we're going to type pipe bash. Let's see if that handles it just as well.
Just had a quick question, Eli, while that's running. We're not picking a version of GHC in this install process, so are we going to end up with a problematic version?
By default, it installs the 10.7, so that's fine.
Okay.
Okay. Let's see. Let me look up.
If it is holding us up, we could continue. I'll just launch a Windows VM and do it the other alternative.
There's got to be a way. We could do. We could do the manual install on your system. Let me see. When sh is dash. What type of Linux are you running?
Ubuntu 20, can't remember the latest one. The latest version of Ubuntu.
Okay. Why?
Hi, he can install GHC version 8 in that system with apt-get install GHC.
So with like apt-get, yeah, you can do that. there's no problem in doing like a apt-get install GHC, which will install, I think, version 8, like the other person said. So if you want to do it that way, that's fine as well. So we can try that. So if you do instead of this curl, type GHC. I'm sorry, type apt-get in one word. Space install space GHC, and then press enter. It might ask you to do sudo. Okay, so you'll have to put in front of the apt-get. So press up and then or type it again. Either way, and then you'll probably have to enter your password and so yes, so it's going to be installing a bunch of things. It's installing some curses libraries, some GCC and FFI stuff, which will be for building things that might need C or libc. GHC sometimes needs libc. The only problem here is that the GHC it installs is, if you'll see up there, is 8.8.1, which is behind the 8.10, but it's not. Let me see if there's a way to update to the 8.10.
Okay, I think it worked.
Yeah, no, it should work. Let's see.
I don't want to take up too much of the.
Oh
the
no,
time,
it's fine
guys.
because I'm sure. Somebody's recommending that you do Haskell stack and then install GHC through stack.
That's what I did in my Windows VM. Just I thought I wanted to try a different route.
Yeah.
Can't remember.
Let's see.
Should I just do that?
Let's see. Yeah, that's what I was looking at. Let's try that one.
Okay.
Okay. Then you do I think it's stack upgrade. Okay. And then is it stack install? Let me install GHC.
I thought Stack already came with the UHCI in it.
I'm not sure. So try do let's.
That's right.
Okay. So it's downloading the GHC. So it's installing 9, which is okay. I mean, it is generally the one that's out there. It's not the long term. So if we ever discover that there are issues between the 8.10 and the 9.0.2, we'll figure it out. But yeah. it probably it's going to be okay. So now your GHC is installed and your GHCI is installed. You can do :Q or Control-D or however you want to leave GHCI. If you type GHC, does press enter there? Okay, so that's good. So that's installed. Do GHC space -V, or it might be --V. Okay, 8.6.1. So that's actually the other GHC that we installed. So let's do sudo apt-get. I think is it remove or uninstall or apt-get. A dash between the apt and the get. And then I think it's either try uninstall and then GHC. Okay, so maybe it's remove instead of uninstall. And yes. And then we're going to type GHC-V. Okay, so why didn't that type stack GHC-V? Okay. Woo, okay. All right, so yep, 9.02. Yep, all right, so that seems like it's working. And I think you're good. So basically, whenever we type GHC or GHCI, you just preface it with stack. Okay.
Yeah, that works.
And should be okay.
Perfect.
All right,
thank you very much. Sorry, guys.
No, it's good. It's we're not thrown off. That's this whole lecture is making sure people can get it running because it's not always easy. So anybody else have any issues installing GHC so far? feel free to raise your hand or unmute yourself. I don't see anybody else having any issues. Oh, I see there's people putting up stuff about Plutus, and especially Plutus for M1 MacBooks or M1 Macs. And that is an issue. Running the Plutus code, running and compiling Plutus code, and the libraries that you need for the Plutus environment can be difficult on Macs, because they're not a standard, BSD, and they're not a standard Linux. They sometimes miss the packages that you might need in order for the thing to run correctly. And so some people have made environments to make it easier on you to run it on your system. So if you're running like an M1 Mac variant, then definitely check out the Plutus community, read the docs of that person highlighted, and then definitely use that if you're having any issues. Okay. Yeah, so if your ultimate goal is developing Plutus, whether Plutus application backend or just compiling, say, some servant stuff that uses Plutus code, you probably want to develop on Ubuntu or any other flavor of Linux or regular BSD. But generally, the Debians, the Ubuntus, the Arch Linuxes are generally the way to go. I would encourage the Ubuntu, because when you get to installing all the packages for Plutus, a lot of the pre-compiled Nix stuff is generally only available for like Ubuntu, and generally Ubuntu 20 and below. I don't know if it's updated to have all the stuff for Ubuntu 22, if that's in the cache of the Hydra binaries that they've compiled. It's one issue with Nix that they use for the Plutus Pioneers and Plutus application backend and stuff like that, is it's not the most portable system. Even though it's supposed to be like super portable, it really causes a lot of issues that need to be handled sort of individually, and you need to watch out for a couple of the gotchas for certain things. Okay, anybody having any other issues with their installs? Anybody not installed yet? Okay. If you already have Haskell, you're fine. if you want to use the GHC up to manage your Haskell installations, that's useful. It is not required. So yeah. Ooh, we've got people running actual NixOS. So on NixOS, if you're actually running NixOS, I think the system is pretty okay for running all like the Plutus stuff, but they're sort of midway between, yes, we like Nix and we don't like Nix. We like the Nix shells, but we're not going to enable the Nix builds anymore. So sometimes you'll see these commands in the Plutus documentation that call for like Nix build. And then if you look at like the comments in GitHub or things like that saying like, oh, we discontinued using that Nix build because that doesn't work anymore. So remember, it's still all an experiment on the Plutus stuff. So just that having the NixOS is still good, but just bear in mind that if you see the Nix build stuff, it may not work, and you might have to look on GitHub, or you might have to look somewhere else for any of the descriptions on how to work around that to install the software. Alex, you have a question?
Yeah, because so like you mean Ubuntu is a go-to operating system to develop Bluetooth, and it's like the least issues, right? And if I use NixOS, then it's like there is a way that Nix build, you say, yeah, there's something breaks in Nix build.
Right. Yeah. So Nix build may not work, but generally you don't need Nix build, even if you're running on NixOS, to build the environment that you need Plutus for. So you can still build the environment, but the command that they used to use to build it, they used to use a lot of Nix build stuff, but then it seemed like that went out of style or something. I don't know what happened, that they weren't updating the build files or something like that. And so then it just used the derivations that came from the Nix shell, and you can run Nix shells inside of NixOS just like you can on Ubuntu or anything like that, and it'll download the Hydra binary is, I think, just the same. So I think it's fine.
I was just having issues with Arch, and it wasn't. I couldn't get the binaries, and then I had to reinstall my system, and the NixOS just worked from the beginning.
Yeah. There are places where, so like Arch is fairly hard to configure yourself. Like our CEO Matthias, he loves Arch. But it takes somebody who's experienced in having to build the system from scratch, right, to know how to use it. But with like NixOS, yeah, it's a little easier because it still allows you to have the control over building things from scratch, but it also has all the channels and things that lets you install from not from scratch, or from some derivation of something, and a lot of the stuff, a lot of the work has been done for you in NixOS, so it's good. It's still a good operating system. It's still still Linux still. So it's all good. Anybody else having any problems or installing Nix or anything like that? Next thing, I'll open up GHCI, and we'll talk a little bit about GHCI and when you use it and why you use it. And then we'll talk about using files and how to get those up and running. All right, so yeah, we've had people who had good experience on Arch as well. But yes, definitely. And whatever works for you is good. All right, so let me get the terminal. Oops. Okay, let me share. Okay, so when you start GHCI, you are prompted, or your prompt has this little prelude in front of it. And this is sort of the default standard module imports that Haskell or GHCI thinks you should have access to when you're just typing commands in sort of a REPL-like environment. And so GHCI, while it is, it may look like a REPL, what it's doing is it's actually compiling the code. And it allows you also to do things like read in a file or reload a file that you've loaded from your current directory, and execute commands and use the commands that you've built, use the functions that you've built in your file. And so while GHCI is great, it doesn't really let you, or I mean, you can write functions and programs inside of the GHCI. It's just mostly a place that you want to execute things or get the evaluation of things or look up definitions of things. And so you have access to :help, which gives you information about the commands that you might run. And you might want to do, say, you might want to get some info about integer. So the :I something, :I integer, :I the name of a function. I think you can even do :I prelude. No, wait, :I prelude. You can look up all sorts of things that are available in your prelude.
With map.
What was that?
With map. Use prelude map.
Oh, okay. Yeah. Well, yeah. We'll look up. Oh, I don't know. I don't know if map. Yeah, map. The probably fmap. So you might get a functor map here, or a definition about a function, right? So there are functions in Prelude. There are functors in Prelude. There are types in Prelude. There's all sorts of stuff. There's commands like that tell you more about each of these things. And sometimes you see some information like I showed here with integer, where integer comes in because of the prelude, but it's really in a package that's called integer. What that does, so the prelude brings in under prelude.integer, but really what it's doing is it's importing another module that's called integer, which may or may not be in, is in ghc.integer .type or ghc.integer. We'll talk a little more about all this stuff next time. I just want to show you that this is what the interactive GHCI, that's what the I stands for, interactive. You can evaluate things that are happening in the little shell that it gives you. And then when you are loading things, so you might, so to exit GHCI, there are a couple of ways. You can do Control D, you can do :Q. I think there's another couple of ways to exit. And where then if you go back into it, it'll still have the commands that you typed previously. Sometimes if you do like Control C, or if you do a Control Z and then you kill that process, it may not have access to the things that you typed previously. So exiting the normal way, either with :Q or Control D, lets it make sure that it cleans up and saves what you've typed in there. So GHCI, you can load files, you can load modules, you can load the prelude, which automatically gets loaded, and learn about the types and things like that. So we'll talk about more about that later when we start talking about what the actual types are and what a typed language means and why we want a typed language and why it's important to go on from there. But here today, really just focused on making sure the system works. And you might have you might want to create a Haskell file. So in this Haskell file, you might you might define something. So you'll see it's now trying to index and run the Haskell language server on my NeoVim. I don't have anything in the project in the directory, so it's not gotta do very much to figure out what's going on. But if you did, oops. Well, we'll talk about writing actual programs next time. But when you load something, you can create a file, and then you can load the file in GHCI and execute functions that are in that file, or operate on some of the values that are created in that file. All that stuff will be available when you load in that file. So you load the file. There's nothing in the file. There's no module. It is a module. All files are modules in Haskell. I think you can have several files to a module, but I think they all still call themselves modules independently, each file. The thing is, when it compiles that file, it compiles the functions that you've built there, or compiles the values. So you have access to those values in here in the GHCI. And if you see, it says compiling main. Generally, for every program, there has to be a main. And it sort of infers here that there is a main, and that the eli.hs file was actually the main file when we loaded eli.hs. But generally, you create a file called main with the main function in there. Anyway, we'll talk about that later. But I think, I don't know, let's see, what can we, I thought we would have more problems on people installing things today, so I didn't really plan for us to learn anything today. I guess we can talk a little bit about what it means to be a functional programming language. And what it means is that functions are really the prime construct. So you create functions that operate on values, and functions return something, and then the results of a function are collected by another function sometimes, and you do things like chaining functions, and you can do things like composing functions, and like you would in any math application, right? Compositions of functions like f of g of x would be, first you evaluate g of x, and then you evaluate the function f of x of the results of g of x. And similarly, in Haskell, you have that type of understanding where you can compose functions, where you do the output of one function is passed into another function, or the composition of functions allows you to lazily, so Haskell is a lazily interpreted language, or lazily, it lazily executes. So you could compose functions, and then it'll attempt to create the fastest, most efficient use of that composition of those functions. Sometimes that means it can evaluate those functions ahead of time. Sometimes it means that, or it can evaluate the composition of the functions ahead of time rather than evaluating the value at the time. So it's very efficient for certain types of functional constructs. And so does anybody, I mean, does anybody have trouble understanding what you might, why there might be a relationship between math and programs? Does anybody not have any experience with programming and say, or maybe even not any experience with math and say, what does that mean? What does composing a function mean? Anybody have any problems with that? Okay. Yeah, so I should have like a whiteboard here or something. Maybe I can, there is a whiteboard. I just don't know if it records on the thing. We'll try it out. So you're invited to the whiteboard. And if it, hopefully it records, but you might have some function. F of x, right? And you might evaluate f of x where x is equal to 3, if I could draw. So you might have f of 3, right? And then if f of x is actually f of x is equal to x squared, then f of 3 would be equal to 9, right? The way Haskell works, right, is you have some function. It doesn't get evaluated. You might have f of x equals x squared. You might have the square as something in your function, and you might evaluate that function at a particular point. What it does is it waits till it has whatever that point is, whatever that that 3 value is. It waits till you have that 3 to evaluate that function. And then it only evaluates when you need that 9. So when you need the result of that 9, if you're returning that 9. Otherwise, it just keeps this f of 3 in memory until you need it. So it doesn't execute that f of 3 until you actually need it. And then in math, you might have f of x, and you might have g of x. Ugh, this is terrible. I should put a pen here. Then you might have 3x here. Okay, so this is a bad example. Maybe that should have been something else. But then you might compose these functions, and you might say f of g of x and for a value like 3, so you might have f of g of 3, and so f of 3, this is terrible, equals, oops. So g of 3 is 9. 3 times 3 is 9. And then f of 9 would be 27, right? So 9 squared. The way you would write this in another way is the composition. So you do f of x with a circle in the middle g of x, right? Actually, I think it did that the backwards way. Anyway, so it might be, I think it's g of x composed f of x. Anyway, the idea here is you can write this a different way. And in Haskell, the way you compose functions is you use the dot operator. And we'll talk about that later, but it has very close connections with math. And so, like we were talking about earlier, there is some relationship to proving math functions and proving Haskell programs. Anyway, so let me look at the chat. Let's see. There's some stuff about invocation for me. Okay, so there's some questions about mutable state. There's some problems. We got people with libgmp. Okay, so who's the person that has the lib? Mario, you have some problems with libgmp? Are you able to unmute yourself? Oh. I see you unmuted yourself, but I'm not hearing you, Mario, if you're talking. Yeah, I'll answer some of the other questions until I hear you talking, Mario. Okay, so there are mutable states. So there's this idea in Haskell that functions should be as pure as possible. And that means that there's no input from other sources. You create the functions so that it can have a fixed cost of running, that it'll be evaluated in this same way. So they like to create these pure functions. So functions that have no IO, that have no reading from databases. They like to create a function that does one thing and operates on data. And you might think, hey, well, that's kind of silly. I mean, the world has data, right? The world has interactions with APIs. The world has, resources that you need to go get on your local machine from your drive. So it needs to be able to access that. You might be running, you might be able to run like PostgreSQL, or you might run even SQLite or something on your disk. And you might say, well, I need to be able to access that data. Then how do you create functions that do that? And so there are ways to tell your function, or to tell the computer that's compiling your function, that the stuff you're going to be doing inside of your function has some interaction with the outside world. And we'll talk about that more when we get to that sort of section in our lectures where we actually talk about real code. So unfortunately, not today. It takes a little bit of time to get worked up to that stuff. And then, all right, there's another question here about for loops. So the idea is that there's no such thing as a for loop in a functional programming language. You map over things, and you map until you get a value that you want. And then at some point you stop mapping, or you don't evaluate past a certain point, or you're taking the first n elements of a list and mapping over those. That's generally what you do for loops. So you don't do a for. So you don't do for with something that has some update to some value outside of the for loop, that sort of thing. You don't do that. You do these evaluations, you create functions that evaluate a certain set of data or a certain evaluation of some code that comes in from an API call, or you whatever is going on there, whatever you need to evaluate on there. Okay, so there's a question about invocation. What does invocation do? Okay.
Eli?
Yeah.
That particular question was in response to Alex, and he was responding to my question where I was using the word invocation to indicate preserving a value between invocations of Plutus or Haskell code. That's all that is.
Okay. All right. Okay. Any more questions? Okay, so why don't I open it up now for questions that people have about what we're going to cover. I'll go back to the course over the outline of what we have for the course. Let me just bring it up. That is not what I wanted. Actually, Victor, I'm going to make you host if you're still there. Do you have the outline with you?
Yes, just one second.
I'm going to make you host, then you can make me host afterwards.
Okay, so the outline is here. I just shared in the chat the link.
Okay. Oh, I'll do that. I'll share. Make me host again.
Okay, done.
Okay. All right, so oops. Here's our overview, right? So we're preparing the coffee bar today. We're just making sure that you all have your environment set up. And the next time we're going to be going over what the types are, and we'll talk a little bit about programming an example, like under evaluating whether a string is a palindrome, which is a standard functional programming challenge that is like the earliest functional programming challenge. The reason they do it a lot in functional programming is because it entails going over a string, reversing strings, and operating on something from, say, two directions. And so it's something that functional programming languages really do very well. And so it's something that you can do very easily with the Haskell language. And so today, just make sure that you've got your system up and running with GHC, either through Stack or GHC up. You can rewatch this video. You can ask me. I'm on the IO Discord. I'm available. You can email me. I think my email is connected to the invite, and we can address problems on your particular system if it's not working, or if it is working and you really want to start earlier, I can point you to some resources. Somebody put out the Learn You a Haskell.
Yes, and Eli, during the session today, I've also created a channel under the Catholic School. I'm going to share again here.
Okay.
So we can discuss between sessions there as well and help each other.
That works. Yeah, definitely join that. If you need any extra help making sure your system is up and running, that's probably a good place to share. Discord is great for that. Anyway, so then week 3, we'll talk about Haskell programs. So writing those files and creating a function, creating a program that does something with your code, right? And in that 3rd week, we'll have our first example of trying to do something coffee-based. So something related to coffee will be our first programming exercise, week 3. I mean, you'll do some programming in week 2, but week 3 is where we really kick things off. Week 4, we'll talk about filtering, mapping, things that you might know from other programming languages. Like you might do a filter, you might do a map, you might do a reduce, you might do those things in like JavaScript. And that's great, but those ideas, they come from functional programming languages. They come from this idea that the only way you can deal with modifying arrays or something, or a list in Haskell, or a slice or something, is to map over that list. And so we'll talk about that on week 4. Week 5, we'll talk about sort of the pure and IO. So somebody asked about how you go to a database, or how you go to yeah, they were talking about Redis or something like that. Yeah, you need an IO function, a function that really understands that it's going to be waiting for some stuff, and it's going to have side effects, and it's going to have you know, it's going to alter some data that's outside of the program. And so it doesn't expect every time the program is running for it to be the same value, but it expects or the same evaluation. But it does understand that there is outside world influence. We'll talk about the filters that we talked about here in week 4, but we'll compare them with folds and recursion and best ways to calculate Fibonacci series using using Haskell. And then we'll do a week 6 check-in about how people are thinking about those projects that I talked about earlier. So we want you to have a project in mind at least before week 6. And we can definitely talk about those things in the Discord channel on the Catalyst School Discord. But definitely reach out if you have some questions about what you'd like to do. So you want to make your project moderately ambitious, but not so ambitious that in 12 weeks or even in 6 weeks, you're not going to be able to complete it. So the best idea is to have a plan that you could complete within 6 weeks based on maybe some of the ideas that you're learning. And you may want to learn about some of those ideas earlier than when we cover them in the class, but that's up to you. We're still going to cover them at the same rate throughout the class. We're going to talk about monoids. We're going to talk about functors, monads, sort of nested cases and validation with maybe, and then either, and then also talking about error messages. And then we're going to have in that last week, we're going to talk about what the presentations are. We'll talk about that on the 11th week, and then we'll talk about presenting them on, or we will present them on the 12th week in 2nd of September. So any questions? I think we might end up a little early today, unless there's questions today. Okay, all right. So I guess we'll end. Oh yeah, Victor put my email up there. If you need to get in contact with me, email me at eli.salkin@locksync.com. Oh yeah, so the question is monoid, not monad? Yes, monoid, not monad. Different ideas, similar, but different. And what they mean is a little bit different. Okay. All right. So I guess that's it. I'll stay on for a little bit longer, but I'm not going to cover anything more for the how to get the invite for next week. You just go to the Calendly link, the same link that you did to get here, to get this Zoom link. You just look for the availability for next week, and you click on next week, and you join the session that is for next week. What that does is it just joins you into the group to schedule for next week. Thank you, Nori. The Zoom link will not be the same each time. This is because Calendly is setting up the meetings. Calendly sets up a new Zoom link for each session. I understand 4 a.m. next week for some people. I am sorry. At Locks, we have a bunch of meetings before this, so unfortunately I can't do it any earlier or any later. But we really appreciate your attendance, and and that is what the coffee is for. So make sure you have your coffee. 4 a.m. needs a lot of coffee, so I definitely understand that. All right.
Thanks so much, Eli. See you all
Thank
next
you.
week.
Thank
Thanks a
you.
lot.
Thanks, Eli. Thanks, everyone.
Thanks so much, Eli.
Bye-bye.
Thank
Bye.
you. See you around.
Bye-bye.
Bye.
Graphs of Victor.
Eli?
Yep.
Hello?
Yep.
I have a question, which is like, I'm not sure, it's like, I'm learning Haskell, and the thing that I'm like planning right now, there is this module which is 9 years old and it doesn't run. It reports, yeah. So what I'm like, just if you can suggest an approach, like, should I try to make this module run, or should I just like read through the files and see what functions I need and try to figure them out and copy them to a new module and like start it from a new?
That is a really good question. What is the module doing that you really wanted to use?
It's a domain-specific language for game theory. It's like to model games.
Oh boy.
Yeah.
Yeah, that is pretty specific, right? In that case, if it doesn't run, I think you do they have like a GitHub with their code in it?
Yeah, for sure. They have a
Okay.
GitHub. I forked it. And also they have like large doc in a PDF and somewhere in Cambridge or somewhere there, somebody wrote it like 10 years ago and I forgot about it. Yeah. I just want to use it, and it seems to be well documented, but it reports error in somewhere like I run it and it's like 3 or 5 errors, and like the first one is in monad. Maybe I should send you an email, and you can help me figure this out.
And I'll take a look at that.
That'd be awesome.
See if I can.
Yeah, thanks.
No problem.
Yeah, thanks. So I was looking for someone to like just show it, because I'm stuck with it.
Yeah, definitely. Or put it up on the Discord.
For sure. I will share it. Like it's a side
because
project.
maybe somebody else wants to work on that as well. Maybe somebody will work with you.
Yeah. Thanks a lot. Okay. Bye. Thank you.
Ellie, I do have a question. I'm using replit.com as my to be able to code. So I haven't done the installation on my computer because I run Windows, So would it be okay to continue with replit?
Yeah, so I've never used Replit, but I know that it allows you. Does it allow you to upload files so that you can load the files? I don't know.
I don't think so.
Let me see.
I mean, I haven't done it yet.
Yeah, no. I wonder. I'm gonna take a look. I'll take a look right now.
I was able to run GACI and also so
let's see.
I'm taking classes with the Morgo. With the Morgo.
Oh, okay.
And, and it's been such a great core of knowledge. I need to practice a lot, and that's why I'm joining, because this is super good for me. It's a way for me to understand better and start doing. That's why I wanted to specifically this class for the setup environment.
Let me see.
just become a member. And
I'm gonna create a class on
exactly.
Replit. Let me see. Haskell Coffee. Create a project. We want Haskell. So there is Haskell Cabal, which means probably that you can load files.
it has
Yeah, it does let you upload files. So I would think that you should be able to load them. Yeah, so like you can edit your main HS. Oh yeah, yeah. That you can totally use that, definitely.
great, great.
It
would be a good idea to open a class there so you can have.
Yeah, I'll look into that this week.
To that.
Yeah, that might help. Yeah, I've never used Replit. I know that. When it has the console, it's using a slightly older version of GHCI, but not like terribly, not terribly old.
Let me see this version I have.
Yeah, it looks it's a little slow, but it's okay. Like I did get information about integer on GHCI in the console, and it's still thinking. I don't know. Maybe if if you click run. No, I don't know. Okay, I'll figure it out.
I just wanted to bring that up, and yeah, I may be sending you one email with our questions.
Sure.
See how it goes. Wonderful. Thank you very much. Hey, Victor, thank you so much, man. This is awesome. I love it. You guys are doing making a difference. It looks super.
Yeah. Good to have you here.
Thank you, man. Thank you.
Thank you, Juan.
And you have a great crowd. 35 people. Awesome.
Yeah. It was even larger at the like 39 people came.
Exactly. Oh yeah, I just saw 35. Yeah, but yeah, that's a great thing. I mean, I'm not a programmer at all. I have no knowledge. I mean, no background. But I find that learning Haskell is a great way for us that we are not programmers to start understanding all this, because we all know functions in mathematics. I mean, it's kind of a given. So it's like a different way to think. So it's tougher for the programmers to come and learn Haskell than for us.
Yeah, it's tougher for people who've had experience with programming in other languages to start programming in Haskell than it is for people who are new to start programming in Haskell.
Exactly.
So it's one of those unique experiences for people.
Right. The only thing is that we have to take the time, and that's my biggest challenge. Focus and take the time to do the exercises, internalize it. But yeah, that's what I'm here for. Anyway, thank you very much. We'll keep in touch. I'll see you on next Saturday. Actually, not throughout the week.
Yeah. We'll be around.
Okay. Take care. Take care, Victor.
Thanks.
Thank you, man.
right, I think I'll close us up. Thank you all who are still here.